Hello and welcome. I'm Bill Wake. We're working on Parser Combinators. We made a lot of progress over the last few weeks, and then I took last week off for vacation. But we're back this week. We're going to try and finish up the Parser Combinator library. And then my hope is next week we'll try and integrate it into the basic interpreter we did before this project. All right, and today we want to start with the sequence operator. We've got combinations we want to do yet. So let's see, sequence is this ampersand operator, less than, ampersand, greater, and we have two versions already. One is if you've got an array of a type and an array of a type, you combine them. I'm pretty sure we have that one. And the other is if you have an element of one type and an element of a different type, we return a tuple. But what we'd like to do is get arrays as much as possible when things are corresponding, when they match up. And so the first two handle the case where the array's on the left or the right. And then the third and fourth one there, they can handle situations where something is required, but we only need to return one of them. So x less than ampersand y says both x and y are required, but only keep the left hand, only return the left hand element x. And then x ampersand greater y says only keep the one on the right. So think about if you do a comma list, expression, comma, expression, comma, expression. You don't really need the commas for anything. They were just there to separate things syntactically, but you don't really need to keep them to build the parse tree you want. Okay, and then the rest of the work we want to do, we have a question: does the tuple version need to enforce different result types? I think I can answer that it doesn't need to. It tries to pick the best one, so it gets it automatically. And then we want to do a few more. One is the optional operator, either a question mark or a slash, and that means return 0 or 1 and the optional type. And then the next one is it's a sort of higher level operator, x comma y. That's for those cases where you have commas. So if you have expression, like inside parentheses in a function call, you have expression, comma, expression, comma, expression. You'd write that as the expression, comma, operator, comma, a parser for comma. And then it would match x and 0 or more, comma, x's. So expression, 0 or more, commas, and expressions, and then it will return depending, it just returns whatever the result of that right hand side is. It could be tuples or arrays. Another variation is only keep the left hand side. So x less than comma or whatever we have to do is the same, except notice the y and greater x instead of the little spaceshipy one. That way we'd throw away the commas, and so it would naturally be an array of x's. All right, I have a few more, but let's see if we get through these first. And I don't know. I don't think it's going to take us all week to do them. Whoops. All right. It won't take all week to do them, and I'm off Friday this week. So even with a short week, I'm pretty sure we'll get through them all. All right, so operator variations. Let's start with this array plus same. Okay, and this is and then. And let's see what we have. We have and then array. Oh, what is this one? Input is p.input. Target is p.parser. They're both the same type. Oh, this is not quite the one we want. So I think I want to change the order of these. Well, let's run tests. We haven't been here for a week. Okay. I don't know if you caught, I did an unexpected session Saturday a week ago. I put pcombo in its own library and got that working. So we have a separate project for it now. All right. Those all work good. I'm going to move this. I think and then tuple is sort of the most generic case. So I'm going to put it first. Refactor. Okay. So this one, the input of the two is the same. So they both parse the same stuff. And the target is the tuple of the two of them. Okay, so this is two arbitrary parsers. This one is two parsers that are the same stuff. Now, I don't know if we're going to get some conflict here, but we want to do a case that's array and element. Okay, so let's get over to the tests. And then tests. And then array matches both items. Okay, so this is two ints. I'll just borrow the test structure and put down here. Okay, so this is, and then array element. Yields array. Okay, so sat1, match 1, match 2. Well, okay, let's make this a sat3. And actually, I think we can use this kind of notation. Okay. If you take sat1 and sat2 and sat3, okay. Now we match this input. We'll do this. Okay. Type of int is not match. Okay, that's fine. All right, so we have a little parser that can match 1, matches 2, matches 3, and then we string them together, sat1, sat2, sat3. Well, these two, if they were the only two, that would yield an array because they're two identical types. They yield integers. But the result of those two is an array of integers because of our array parser. And so when you try and combine it with sat3, you've got array of int plus int. And we want to make sure that ends up in a big array. All right, so let's go back up here. And I think it's going to be more like this one. So much like it, I'm just going to borrow the whole thing. Okay, so I can call this and then array element. Okay, so P of parser, and I think we're going to have to make these two different ones. P1 of parser, P2 of parser. Okay, they're two different parsers. The input is input type is P2.input. The target is P1.target because it's already an array. Okay, so, and then array element was good. Okay, so input is P2.target, right? And then I feel like I gotta have a where clause somewhere. I gotta tie these things together. array slice and then element array slice. Ugh. Okay. P1.target equals array of P2.target. I hope this works. Oh yeah, equals. I keep making that mistake. Oh, come on. Yes. Okay, good. All right, so my target type on P1 side is an array of P2s, and P2 is the input. Type alias P1 is the target. Okay. Now, what's the deal? Oh, I guess P1.input equals P2.input. And P1.input equals P2.input. Let's say that condition goes first. Okay. Fine. Well, let's put the comma up here. Okay, they have to parse the same kinds of things, and the target has to be the proper target. All right, now this. Okay, so we want to get the success case. I'm not going to worry about the failures just yet. All right, so we parse target 1. We parse the input for parser 1. If that succeeds, we parse 2, and then the thing we got to build up is, well, it's really target 1 is the array. Oh, well, let's just, I don't think I made it fail yet. Oops. Okay, cannot. Well, let's see if I've got it building. No. Cannot conform to equatable. Why was that okay up there? Okay. Type array event to expected argument type and then array. Oh. Looks like it's trying to come back with a tuple and then array and int. Array int. Does that mean I've got something wrong here? Oh dear. Okay. Okay. Let's do a build. Oh. Did I get the output type right? Oh, I don't have an operator. Okay. Let's take this. And P1, P2, parser P1, P2 goes to, and then array element. And I don't know if I have to put some wheres on this or something. Okay. So we were calling the tuple parser because that's the only one that matched two separate parsers. This one requires two identical parsers. Okay, I feel like I'm missing a case, but that's the bigger issue. We'll get to it later. All right, build again. Very good. Okay, now let's try the test. Should fail. Should get 1, 2 back. Yeah, because sat1, sat2, we're returning result 1 or target 1, so that's the array of the first two. Okay, now let's do this. We got target 1. I think target 1 dot append. Oh, sorry. Oops. Result dot append target 2. And then return result of our that's clearly wrong. Okay. Okay, and let's check our test. Okay. From all. That was too fast. What's up? Really? I guess things are better than I expected. Let's just make sure. Okay, the case I was worried about is what if I have an array of E and an array of E? I think I'm going to get a tuple back, but let's check this in. So we added for array plus element yields array. Okay. And all right. August 1st. Rabbit. All right. Let's get this one. Same plus array goes to array. Yeah, this one I'm not as sure I need. I guess I do. If I have sat1 and then parentheses sat2, sat3, I want that to still be an array of stuff. Okay, let's see. Now, I guess I should talk about refactoring, but I kind of feel like it's hard to know. Oh, we should do the failure cases. Let's go back and do those. Okay, so we just need 2 cases. And again, I think these are going to be similar. And then array element fails if first item fails to match. Okay, so this is the same. This is the same. Result equals parse. Okay, so first element fails to match. Let's do 4223 would be fine. Okay, failure. Position 0 did not find expected value. Yeah, that's probably okay. And this should just pass, and then this one. Okay. Yeah, maybe I should make this test. I'm going to parenthesize these just to be extra clear. It's implicitly there, but I'm going to make it explicit. This is 125. Position is 012 because we're not matching the 3. Sat1 and Sat2. So I think I would actually be better off if this were 142.23. So I'm gonna fail the second position, but it's still the first parser fails. Okay. And I believe these tests should just both pass. Yep. And we can force this. Okay. Good morning. So, well, good morning for me. So we're doing this thing called Parser Combinators. And what it is it's defining, so you define some simple parsers like match this character or match this item, and then you build up the parser combinators or combinations of parsers. So if you want to match A, then B, then C, then you have a parser combinator that says, give me the parser for A, the parser for B, and the parser for C, and I'll combine them all together and make one big parser out of that. And so what we're trying to do is the case. We're doing cases. This one is the append. So I expect to see a 1, then a 2, then a 3 in order. And if I do, I should get an array of results. So let's go up here. I've got 1, 2, 3, and I see 1, 2, 3. And then I get an array of 1, 2, 3 out. And then 4 is my rest of my input I haven't processed yet. And so I'm trying to cover the cases of, like when I combine two things that don't have the same type, I get a tuple. If I combine things that have the same type, I should get an array. Then if I combine an array with an element, I should get an array. And if I combine an element with an array, I should get an array. And I think I also have to do a case where I combine array plus array, but I haven't looked at that one yet. Okay. Yeah, so in this case, I'm specifically testing, we got this working, and I've got a couple error cases that kind of came. I mean, this is to some extent noticeably copied. Okay, so let me, I just want to force and make sure my error messages are really being detected, that I didn't just get the test for free, kind of. Okay, that's a problem. All right, let's run these all. Both those should fail now if I'm modifying the right thing. Okay. And then tuple fails if first parser fails. Oh. I'm not modifying the right thing. And then array. Should be in an array element. Okay, yeah, this is the one. Okay, now I should get 2 different tests failing, the last 2 in this section. This is Swift. We're not doing any GUI kind of stuff at this point. It's all just kind of a parser library. So, and it's been a nice language. It's kind of it's big, but maybe not as big as C++, but certainly bigger than Java. Yeah. I mean, and it's similar enough. Most of what you read is the same. Maybe this stuff is a little different. How you set up your own operators that's not this way in C++, but yeah. Let's see. So, okay, yeah. So the right 2 tests failed. Let's fix that code back. Okay, and all tests should pass. And let's commit. Okay. Check failures for array plus element goes to array. Okay, and then the next one we want to do is we want to do the case of an element, then an array. So it's kind of these same 3 tests. One on there. And then element array yields array. Yeah, it's 80% the same. The generics are a little different, but yeah, and there's extra keywords and stuff like that, but it's pretty close. Okay, and then element array. Let's fix these names first. Okay. And then element array yields array. Okay, so this one, I want to parenthesize the parsers the other way. And I'm not sure if this, yeah, this should do it. Okay, so now I'm combining an element, matching an int with these 2 that should match an array, should yield an array of ints. Okay, and in this case, I want them to match the same thing, but the type's not going to agree. Can't match int, this type, to int array of int, tuple. We don't want a tuple, we want an array. So that's where our code is not going to be there. Okay, and this one we'll come back to, but I think it's going to be the same parentheses. My guess is that's probably the right test, but we'll come back when we're ready to really look at it. Okay, so this type does not match, and let's go here. And again, unfortunately, I don't know a way to make, there's duplication across these, but I just don't know how to get rid of it because of the type matching stuff and all that. So let's copy this. We want and then element array. P1 input equals P2 input. P1 target. Actually, it's more the other way around. P2 target is an array of P1's targets. Okay. The input, well, this can be P1 because they're both P1. Probably that one could have too. Okay. They're the same, so it doesn't matter. The target is really P2.target, though. We want the array to be the target. Okay, we have two parsers. The resulting type. Well, it's like result equals target 2. I'm just going to get a wrong answer first here. Okay, result is target 2. And if result was never mutated, oh, fine. No, I don't care about that. But this, did I miss a brace? Okay. But now we need to support this one. Okay. P1 a parser, P2 a parser goes to and then element array. Okay. So we're covering the variations in the operators. Oh, what's the problem? Cannot find and then element array in scope. Well, and then element array. Okay, I think that's there. It's just slow catching up. No, apparently not. And then test, and then test, and then tests. Okay. Cannot find and then element array in scope. And then element array. And then element array. Oh, I did mess up the parens, didn't I? Okay. Got an extra one here somewhere now. I guess all this can go left one. Okay. Mutated, but it found everything. Okay, and then my tests. Let's run them. Notice the message went away on this. Okay, 1, 2, 3. That's because we only took the second argument. We didn't build up the array. Okay, and this one, basically we want the array with target 1 on the front of the target 2 array. I don't know my Swift enough to know how to do that. Prepend. That's right, for single element. Insert. Okay, I guess I can insert value at 0. Let's see if there's just a little helper for just that. Insert value at 0. No. Okay. Result equals target. Result.insert target 1 at 0. Run all tests. Okay. Now let's get these two. And again, I think, let's see, we copied a structure that had the test cases for the failure examples. So this one, we got sat1, first item fails. So we need to make this test sat1 fails. but sat2, sat3 would succeed. Okay, so failure at position 0, because sat1 fails. And then this one, 2, 5, sat1 succeeds, sat2 succeeds, but sat3 does not. Okay, I think that should pass, and then we'll just muck it up a little and make sure it can fail. We never saw that test fail, so I'm forcing it to fail by mutating my code. And this should fail 2 tests. Okay. All right. And all tests should pass. And let's check this in. Element plus array goes to array. Okay. Now that leaves a case that I didn't consider before. Array plus array. I think the way it is now, this will be legal, but it won't give us quite the result we want. Let me write a test for it, and then I got to decide if I really care. Okay, so let's just take the base test like this. Okay, so if I'll pick a set for, okay, so this case would correspond to sat1 and sat2 followed by, I guess I should have done that, sat3 followed by sat4. Okay, 1, 2, 3, 4. Let's put a little extra input in. 5. In some world, we would like this result. Okay, we just want to sat1, sat2 form an array, sat2, sat3 form an array, or sat3, sat4, and then the whole thing is an array. Cannot convert value of int to expected type array of int. So I thought what it would do is this. Let's see if that's, yeah, that's the type we'll get back. Yeah, that's what it does now. Okay, and the question is that acceptable? I think I'm going to leave it for now. Yields array. I'm going to document what it does. And this is a consequence of the existing stuff. If I really wanted to return the flat array, I would have to deal with it. I'd have to do something else. Okay, so I may need that case in the future, but I'm gonna push forward. This is let's just say we documented this one. Document array plus array goes to array of array. Okay. We can always do a flatten, so maybe it's not an issue. But I want to move on. Okay, I think this one we already know the answer. Don't have to care about that. Okay, so now I want to do these ones that only return the left or right elements. So if you do A less than ampersand B, it checks for both, but it only returns the left one. So you can ignore stuff like parentheses. So if we want to match a parenthesized expression, let's say like 3, okay, we could say left paren, ignore it, number, right paren, ignored. Okay, so this would match the left parenthesis, it would match the number, it would match the right parenthesis, but when it matches these two, it only returns the right side, so it just returns the 3, and when it matches these two, or matches the whole thing, it only returns the left side now, which is also 3, so it just returns the 3 out of the middle. The parentheses you don't have to care about. Okay, so slightly useful. I mean, I think you'll use it a couple times in a grammar, you know, for a language. Okay, let's add it. Okay, and it's still an and then. Okay, this one, I guess we don't care. We got 2 different types, but we don't care about them. So it's kind of like this tuple one. Okay, so let's it's really and then ignore. Which one are we doing first? Keep the left. Okay, let's call it keep left instead of ignore left. Keep left. P1, P2 have the same inputs. That's required. The target is really P1.target. Because we're only keeping the left. Okay. And then here, let's, I don't know how we fail this. It's even hard to write a failing test for this. Okay, let's see what we got to do. All right. And then well, we'll just take this test. And I don't know, I may need to split up these. There's a lot of stuff that's very similar. And then keep left. Fails if first item fails to match. I think I copied the wrong one. Okay, and then keep left yields left. Okay, so we don't need a third one. So this is just sat1 and sat2. And it's the keep left version. Okay, if you parse 1, 2, 3, 4, the result should just be the 1. I'll drop the 4. Okay, so it's going to consume 1 and 2 and return 1 and leave that on the rest of the input. Okay, we don't have an operator defined. And then keep left. Okay. Now, I don't know how to make this fail. Well, I suppose I could return a failure. Okay. This test should fail. Oh, cannot find it. Oh, I need an operator definition. Keep the same precedence. Okay. Try that test again. Oh. Cannot convert value of type int to array event to expected argument type int. Have I messed up something? Keep left. And then keep left. Okay, I don't see where array event comes into it. Cannot convert value of type array event. Oh, it really is just an int. Yeah. Because the left-hand type is int. Okay. Now this should fail with failure. Failed. Result was 33 wrong. Okay, good. This, now we just return target 1. Remaining one, we don't even care what the target 2 value is, but remaining 2 is what we got to return for the rest. Okay. Immutable value remaining 2 was never used. Really? Okay. Remaining 2 was never. It's behind. Yeah, I don't care for those situations. Yeah, I've been burned by the mock stuff too much in a lot of ways. You know, just I'll walk in and see tests and it turns out nothing's being tested and stuff like that. Sometimes you can build up little helper functions and stuff so the test becomes just a couple lines of setup and that helps. But yeah, that's a tough one. I will say I don't tend to test GUI components directly too much, and then same for DB. I mean, try and flip it around so it's not a focus of the test, but sometimes you got existing situations and you can't do much about it. Okay, let's see. So we got stat1, stat2. This time we want to fail if stat1 fails. And the failure's at position 0. All right, and then I'm just going to muck with this so it definitely fails. Okay. Okay, why are you wrong? Oh, I didn't muck enough. Unexpected success. It's just as bad. Good. This should be the 22, yep. Okay, let's take that one out. Now, I clearly have garbage here, but none of my tests catch it, so I need to write that last test for this. Whoops. Oh, okay. So, wait a minute. Failure 3. Did not find expected value. Why would this start failing? Okay, let's get this test in and fix it, and then we'll see. And then keep left fails if second item fails to match. And it got as far as the second item. Okay, this test should fail. Okay, it should be the 22. Or, 33 still. Yeah, okay. So let's take this off. And run it again. Now, I don't know, the array of array things, we got to see what's going on there. This one's fine, but the array of arrays... I must have not run tests fully or something, because I thought we ran this. I know we ran this. Okay. Got a failure at position 3. 0, 1, 2, 3. Is that 4? I never could have passed, huh? Okay. I'm a little puzzled. I could have sworn I ran this and it passed. But anyway, okay. And less than, keep left. Okay, and then the last one, we need the keep right one. Okay, so let's start with some very similar, familiar tests. This is, we're going to spend a little work on some test cleanup too, I think. Okay, this is keep right yields right. Okay, so ampersand greater. Set 2 should give us the 2. And then this one, then keep right fails if first item, wait. Keep right yields right. Yes, okay. Keep right fails if first item fails to match. Yes, that's true. And then keep right fails if second item fails to match. This is keep right. Okay, they don't see the operator. Let's put the operator in. And then keep right. Okay, and we don't have a class for that yet. But it's going to look a lot like and then keep left. So much like it, I feel like, there should be a way. Okay, this is and then keep right. Okay, P1, P2. Input is P1.target. output is P2.target because we're keeping the right-hand side now. Okay. And this, we will return a failure for now. And this comments out. Okay. And let's just muck with these while we're here. Okay, middle remaining 2. Okay. And that should fail all 3 of those tests. Good. Okay, yeah, this one fails. Got a 6th failure. This one fails. Got the wrong index. And this one fails with the wrong index. Okay. So let's take these 2 out first. Okay, we should still have the 1 failure for keep right itself. Okay, just 1 failure. And let's make that work. Okay, so this time we want to return target 2, which means we don't even care about target 1. Ignore that. Remaining 1 we need because it gets that. Target 2, target 2. All right, I think this should pass. Good. All tests pass. Okay. Did I even update this? No, I didn't. Okay, commit this. Now, I really want to see, there's so much boilerplate, like this junk. But I tried just eliminating it and letting the default constructor take it, and nothing. I don't think that works. Let's take this out from, oh yeah, because this isn't public by default. Okay. Yeah, such boilerplate up here. The parse, it has the same overall structure, but it kind of depends which things get, like, how do you get this value here? I don't think I can subclass because they're not really the same. Now maybe they could. P1 input, P2, they have different targets. Yeah. No, there may be an expert who can tell me what to do, but I don't see it. Okay. Let's see. So we have done these. I think I put that down here, right? Yes. Okay. Now we want to do an optional one. All right. Let me just push this too. We're not using this one so intently anymore, but still. Okay. Yeah, so we want to pick up and try and create an optional operator. We have one for 0 or more and 1 or more, but we'd like an operator that handles 0 or 1. But we've been going an hour, so I think let's just take a break, like 3 minutes. We'll come back and see if we can get this one working. I don't think it should be too bad. But we'll get that working and see where we are from there. So see you in about 3 minutes. All right, welcome back. All right, this one. So we'll start with a test. This is going to be similar to many. Yeah, we'll start with a test over here. Optional. Should fail. Good. Okay. So the test for that, I think I'm going to look at many tests as well. It's going to be similar. Okay, so test optional. Well, let's start with let's start with 1 with match. Okay, so if we are looking for a 1 in our input, an optional 1, and I don't know if I can make this operator or not because there's restrictions on which values used for characters here. But if I can do it, I should get back a 1. Okay, so if you have optional 1 and your input has a 1, then that should match and your input should be 2. Okay, so let's get the optional class in place. Well, actually, I'm going to do it the other way. I'm going to do it up here. Class optional and yeah, let me borrow some of this boilerplate. It's funny, there's a bug. It should stop and ask me the file name. Oh, I said I wasn't going to do this. Oh well. Okay, the target is not p.target, it's p.target optional. Okay, so you have an optional that takes a parser with an input type and a target type. We get the parser, and then we have to define the function and come back. All right, optional tests. Let's take that out. Okay, and then we need an operator definition, kind of like this one. We'll just push in a failure for now. Okay, and this should be a question mark and a question mark. It should be optional. Oh, it's going to work. Okay, good. I was worried you weren't allowed to use question marks. I think you can't use them. Oh, maybe. That's public class here. Okay. I think because it's a prefix operator, it probably allows it, but it might not allow as an infix. But that's okay by us. All right. So optional tests. Well, if I do a build, this should catch up. All right, this test should fail because it always returns failure. Okay, 22 error, yes. Okay. Now, let's see. So we need to do a match on our first parse. And again, I'm just going to borrow this. Well, that's more than we need anyway. Okay, so we will attempt to parse the input, and if we succeed, case success of target and remaining, we're going to do something, and case failure, let's just return our result for now. Okay. Oh, well. Let's return the same junk. Since we're not testing that case, I don't care. Okay. Now, this should fail with the wrong thing still. It should be 23 instead of 22. You didn't really run, did you? Oh, there it is. Okay, 23. Okay. Now, if it succeeded, well, then we've got a success. Let's just return it. Success target, and the remaining is the remaining. Okay, so if you actually did match it, it was optional, you matched it, then we should return success. Sure. All right, and so this test should pass. Good. Okay. Now, let's deal with the optional that fails to match. Okay, match 0, 1. Well, let's say we didn't have any 1 at all. We just had the 2. We attempt to match a 1 in an input that doesn't have one. We should get a nil because it was optional type, and the input should stay the same. Okay, so we're just not consuming anything, we're just returning it. This will fail because we return failure instead of success. So notice this optional one always succeeds. Okay, my primary programming language. Gosh, for stuff on Twitch, I've been using Swift for about a year and a half now. When I'm working, well, as a coach, I kind of end up doing whatever the team does. I'd say mostly Java and Kotlin in the last few years. Maybe a bit of C# as well. But yeah, somewhere in that zone. I'm using Swift when I get a chance. I just soon kind of focus on that for now. Okay, so 22 error. Yeah, so in this case, and what about you? What are you working in? Okay, so if this thing fails to parse, well, it's still a success because it always succeeds, but the return value is nil, and the remaining is the input. So that's a little unexpected, perhaps. Okay, we're saying we didn't parse anything, so don't make any progress. Okay, just return success. Okay, and this should pass. Boy, these things are so easy. I had so much struggle to get these types right early on these class declarations with that array stuff and all that. But this is better. Java. Okay, cool. Yeah, I mean Java's definitely coming a long way. You know, there's some nice stuff in there now. Although I have to say I used Kotlin for stuff in the last year, and with a team doing that, and that's a really nice Java. I don't know how popular it is. I mean, this was a company using it, so I know it's out there, but it really was a better Java in a lot of ways. It's got some quirks, but it's all right too. It's not so far different. But Java's still very popular. So, you know, if you're trying to find teams doing that, I'm sure you can find Java teams. Okay. Well, there's no way to fail. So I think we've done what this thing needs to do. Let's see. So let's take this down here. Yeah, we're knocking through stuff. I guess I wish I'd known. Wish I'd gotten going faster. Okay. That is done. Let's commit. And then these two. Okay. Yeah. I wonder if I can use them. It would sure be nice to kind of just lean on the definition. Whoops. Like that. That should be a little spaceshipy kind of guy. Well, all right. This is a comma. Comma. Well, it's going to be similar again. Comma, it's really a P1, P2 case, so it's much more like and then. Okay, and let's get a test in for that. Okay. All right, so this test is comma matching one item. And okay, so let's have 1 and 2s. Okay, 1, 3. And this is sat1, comma, sat2. Okay, so it should be 1 or 1, 2, 1 or 1, 2, 1, 2, 1. Okay, and we give it 1, 3. The result should be an array of 1. Oh no, what should it be? I think it should be a tuple, maybe? Let's see. Back to my definition. Okay, if I have A, and I guess we wrote this as this, many. You have 1A and a type of a tuple, then the result has to be a tuple. Okay, so in our case, the many is an empty array, and this is a 1, I believe. And his input should be, remaining should be 3. Okay, so sat1, sat2, comma sat2, input is 1. It should match the first one, and then the list of the second one is empty. And let's make sure many is like that. Is equals target. Yeah, so it target like that creates an empty array. Okay. I don't know why that one was open, but okay. Comma tests. All right, I think this is what I'm expecting. Oh. I don't think tuples are equatable. Let's find a tuple. Now I have to take it apart. Okay. This is unfortunate. Okay, so I'm going to success equals target equals result. If not, fail with result. Type is ambiguous. Okay, that's because it doesn't know this, I think. All right. Target.0 should be 1. Target.1 should be empty array. Target.remaining should be 3. Target.1.count. 1.count should be 0. Okay. All right, now let's get this class into some semblance. Okay. We need P1, P2. P1, P2. Okay, so where is it then? Okay, we must define type alias. Input is P1.input. The target type is really, well, it's really P1.target and an array of P. What should it be? Well, P2.target, P1.target maybe? I'm not quite sure what is expected there. Okay. And one more print. Okay, so we're going to return a tuple, the first item that we parse, and then an array of the P2 target and the P1 target. So expression, comma, expression, comma, expression, comma, expression. Okay. A little clunky, but that's the way it goes. Okay. And this, okay, I think that's all right. Yeah, we need to close this. Let's return a failure. Okay, just to get something back. All right, does this compile? Where's my comma test? I need an operator. It's more like, and then multiplication precedence. That seems right. This operator should be comma. Does it let me do commas? Okay, and it should be this thing. Not allowed in operator names. Oh, what a pity. Okay, what was my backup? Was ampersand, ampersand? Yeah. Okay, this should build and fail to run. Oh, I need to change that. Result equals grammar.parse. Okay, build. It'll fail because we're just returning a dot failure instead of a dot success. Result was whatever. Result was failure. Okay, good. Okay. Yeah, now we need to do the work. Okay. So I don't really want to do it in the parse. I just want to make an expression. Well, let me try that. Okay, let's try a return. Well, actually, I think I can even leave that out. The deal is I want to do parser 1, and optional, no, many parser 2 and parser 1. Okay, does that correspond to what I set up here? Parser 1 and many parser 2 and parser 1. Parser 1 and many parser 2 parser 1s. Cannot return expression. Okay. Let parser equal that. And then I just want to return parser.parse of input. All right, I kind of feel like this should pass. Okay. Now, I think I kind of get it for free, so I'm just testing stuff that should work. Although this, I may have to work at it. Okay, so 1, 2, let's give it 1, 2, 1, 3. So imagine this is expression, this is comma. I'm going to have two values there. So this target should be the 1. That should still be the same. But target 1 should be an array. Well, yeah, it should be an array with one item. I'm going to break out the item. Dot 0 should be the 2. I don't know, these assertions are getting a little tangled here, but target 1 should be a 1. And the remaining should be 3. Okay. So let's see if I can do the assertion right and instead of talking myself into it afterwards. Okay, so I should get a pair 1 with an array. The array has one element. First element is a 2 and the second element's a 1, and I should get the 3. Okay, I think that's correct, and I think it should pass. Good. And let's do comma fails to match second, no, fails to match second item, I'll say. Okay, so if I have 1, 2, and I don't have a 1, I think my comma operator should say you did not match 1, 2, 1, 2, 1, 2, 1, 2 ones. And so this should be a failure case. Check failure. Actual is result. And the expected is parse result. Well, dot failure. Integer, we should fail the very beginning. And I think our messages did not find expected value. Okay. So instead of 1, 2, 1, 2, 1, 2, 1, we just got 1, 2. So we have expression comma parenthesis. Okay. Int array target. Satisfy int. Well, I don't really want to. Let's try it this way. Result. Hey, thanks for joining. Take care. All right. So this one, ooh, what is going on? Well, the interesting thing is the result type, it's checking equatable, but all I care about is the failure. So I'm going to say case let. Now if case Maybe I gotta do it this way. Caselet. In our case, we want failure position message equals result. Okay. Otherwise fail. Okay. So if it is a failure, we want to assert that position is 0. And message is did not find expected value. Success. Oh, should that be success? I guess that should. Okay, let's do a different test. Let's look for 1, 1, 2, 1, 2, 1, 2. Okay, but we don't find the 1. Okay, now that should fail. I guess the other one, it doesn't fail. If it matches the first parser, it's a success because it was an optional set. Sat2, Sat1 repeated. So, okay, so I think this should pass. Good, except I don't really believe it ran. Did my message not match? Did not find expected value with capital D. Okay, and then the next one. All right, so we knocked off this one. Well, we know it has to be that. And this one, the comma's not going to work for us. So let's pretend it never happened. Okay, matches as this, but ignores the B results and returns array of A's. Yes. Okay, so the test for this. I think we'll have similar tests. Comma left, matching one item. That's this. Okay. It matches the 1. It should get back a 1. It should get back an array. So I think we can check success. Result. Expected target is array of 1 and expected remaining is 3. Okay, comma left matching one item. So match a 1, optional 2, 1, 2, 1, 2 ones. It should be an array of stuff coming back. Okay. Comma left matching multiple items. Again, it's a left. So we parse 1, 2, 1. We should get 1, 1, and consume the 2 and ignore it and have the 3 remaining. Type of expression. Okay, that's probably not a problem. Comma left fails to match first item. Then it should return 0. Did not find. Yes, that's true. And let's make a comma left. Sat 1. Okay. All right. And we need another operator. This should be comma left. And another class, which will just take the same one. Comma left. Okay, so P1's a parser, P2's a parser. They have the same inputs. The target type is array of P1 dot target. Okay, because we're only going to keep the P1s, we'll just make an array of them. Okay, now this, we'll just start with a failure. Okay. This test, well, they should all build. And they should fail. The 3 comma left test should fail. Result was 2 error. Okay. 2 is not equal to 0. Okay. Okay, so now this one, the parser is a little different. Matches is blah blah. Yeah, okay. The parser, we want parser 1 left only, parser 1 left only. Oh no, this one's both. So we get a P1 and that should be right only. And the P1's there. This should be element plus array of elements and give us the right value. And I think all those tests should pass. Did you really run all those tests? It's so fast. Okay, I guess. It failed. We saw it fail, so I guess it's okay if it passes. Very good. I'm pushing over the hill faster than I expected. Okay, so this is ampersand. Ampersand is a comma keep left returning an array. And make sure I was consistent in my spelling. Now, did I add the second argument? I did. Make sure my test uses comma, the left side one. Yes. Yes, and yes. Okay. Sometimes it's just too easy. All right. That is done. Okay, we're knocking through these pretty good today. Alrighty. peak parser. I don't know if that's the right name. Okay, this one is it's sort of a way to let me look. I want to look downstream. Peaks may be okay. I want to look downstream, see if I will match a certain input. Excuse me, match a certain parser. And if I don't match it, then I failed. Then I don't even want to go down the path. But if I do match it, I don't want to consume anything on the input. I'm just saying I looked, and it's sort of a context check that things are looking good. And the example I have, I know we needed it in the basic interpreter at one point. We had, it's something with expressions. We're looking down, like it can only start with a number, a string, or a left parenthesis maybe, or something like that. And if you don't see that, then maybe you can't go down this path at all. But it's certainly okay. All right, and let me trim down some of this. We did wrap. I don't think we need to worry about that. Sep a match. We did that. Set match comma a. Okay, we did that one. We did the map. We did optional. We haven't done bind. Okay, let's add that up here. Bind for recursive or oddly named parsers. Okay. Published open source. We haven't done that. Okay, so I think we're this. Man. Okay. So again, I think that's a little funny. I had another one I was thinking of too. Maybe you just define this on your own, but it was like inject or something where you could just force a return value in there. But oh, that was in my, yeah, let's look at this. Okay, so we did the first four, then we did the optional. Okay, then we did the comma. Let me edit this. Doesn't need to enforce different types. I think we've established it does this. The question mark worked. The comma did not. And yeah. Yep. Okay, so that one's fine. We did all those. Now we're looking at these next ones. Peak, bind, inject. So peak fails if p fails, returns nil input if it succeeds. Usually use it with ampersand greater. Yeah, because you don't need, the nil is not going to help you do anything. Okay, bind lets you define a parser and fill it in later with p.bind on parser, or maybe pass the function to a constructor. And then inject inserts a value x, returns the rest of the input stream. I don't know. I don't know if that's generally useful, and you can certainly write it yourself. So let's worry about the first two. Okay, so peak. And is that a good name? Well, I think you're going to say peak a parser. So we're going to kind of break our case convention a little bit, but that's the way it goes. Peak tests. Maybe I'll make this lower to reflect the fact that they're going to be lower. Import p combo. And we'll need a peak class. Okay. So the test is, Test peak returns nil when it matches. And then another one that's test peak returns failure when it fails to match. Okay. Why these templates don't start out indented properly? I don't know. Okay. Excuse me. So sat1 equals, well, let's just steal it from every other test we've done. Okay. Satisfy 1. Okay. And then let parser equal peak of sat1. And parser.parse of input is 1, 2. Let's give it the full input and capture result and check success. We expect results to have a target of nil, which may not be working. Expect a remaining input 1 to untouched. Okay. Cannot find peak in scope. Generic parameter t could not be inferred. Can I do that? Nil is not compatible. Nil may not be a good choice, but I'm not sure what else to return. Oops. Okay. Public class peak over parser. Probably many is closer. We'll just take it all and trim it down. Input is p.input. The target is, I want to say, this is like void. And maybe it'll work. Okay. Target is void. Okay. And then we'll just do a return failure. 27 error. Okay, peak tests. Cannot find peak in scope. Let's do a build. Nil is not compatible with void. Is this compatible? Cannot conform to equatable. Okay. We'll have to check success the hard way, I guess. We did that for comma tests, right? Oh, if I can't check... This is interesting. So this, is there any value that would succeed there? Oops. In the test, type cannot conform to equatable. Okay. So comma test. Let success equal target remaining. Okay. Target should be nil. And remaining should be untouched. 1, 2. Is that gonna work? Maybe this thing should just return a 0. I don't know what a primitive type would be that would be useful here. Okay, that built. Let's see what it does. Should fail, because I returned a failure. Okay, failed. Returned failure. Yes, good. Okay. So we want to take the parser on the input and then switch result of case success. Let target and remaining. And if we get success, that's really, we just want to return 0 and the input. We don't want to do anything. Otherwise, case failure, let's just return this for now because we're not checking it yet. And this was junk. Okay, does it build? No. Int to result type peak p input peak parse result p dot input int. Okay. Have I got these right? The input is p dot input. Yes, I want to parse whatever it's parsing. Peak is going to parse the same thing. Target is int. Cannot convert return expression of type int. Oh, I gotta say that success. Okay, 0 with same input. Okay, that should be better. And I think in this case then I can just say this. And then run the test. Should pass. Yay, okay. And then the failure case returns failure when it fails to match. Okay, let's do the same thing. I mean, it's probably not the same, but let's see what happens. Okay, so we peak sat 1 on the input 2, 1, 2. Okay, so we're looking for a 1. We do a peek. This should be failure with location and message. Okay, and the location should be 0. I don't think I need that little helper message. The remaining should be 2, 1 still. Still doesn't consume anything, so neither case does it consume. Okay. This should fail with the wrong. Oops. Wrong location, wrong message. Okay. And if it found a failure, we do want to find the location and the message and return them here. Now you might think I could just return the same value, but it turns out it's not really the same type, so it doesn't work. Found it out the hard way. Okay. Build. Run all tests. Okay. Did you really run? Yes. Okay. Yeah, so I think we have peek done. Maybe I could say requires specific parse on input stream, but doesn't consume it. Okay. That's this one. Fail returns this. Success returns 0 stream. Untouched input. Okay. Probably say input here. Bind. All right. I just want a 1-minute break, something like that. A little quick break. Get a drink. Be back very shortly. Welcome back. Alrighty. So we're going to do this bind. We did this somewhere, at least in our spike. So let's go find that. Is it this one? I think I called it recursive. Recursive, yes. Okay. Let's find that again. Yeah, so the deal is sometimes you have recursive definitions. Your grammars are recursive. And when that happens, you can't really refer to yourself until you've defined yourself, but you can't, it's immutable, so you can't define yourself till it's referred to or something. So what this does is, well, we just did it with a variable. We just said you create the recursive type and then you later on define the variable. So let's find the usage of that and you can see it. Okay, here's, well, we've simplified expression. We said, okay, there's multiple digits. I think that was our append to operator then. And we defined this recursive E, okay? So the grammar is kind of like, yeah, it's really this. Digits or expressions. Okay, where expression, so it's parenthesized digits basically. Okay, so we define the E recursive type. Imagine this is E instead of F. And we say there's going to be a type E, a parser E, and you can use it, but you're gonna match with it, match left paren right. Okay, so where's the reference? E. I don't know. Maybe it doesn't give a good example. But well, let's say what the example is. If its expression goes to digit or left paren expression right paren, okay, then I would expect something like let expr equal recursive. Expr is our result type, and then let parser equal digit or well, in our notation it would be digit or well, let's say match left paren. We don't need to keep it, so it's a ampersand greater expr less than at match right paren. Okay. Let me comment these three out. Okay, so parser is digit or match, left paren, expr, right paren. And I think that matches parentheses. Okay, and then you would say expr.bind parser. Okay, so this gives you a chance to define it, then use it, and then hook it in so that it's there, because you got this recursive little twist. You've got to find a way to reference yourself, and the way we do it is let you name the name, and only later create the parser for it. So it's a little goofy, but it's kind of, you got to do something like that. And I called it recursive up here, but I think bind is a more generic name that maybe fits it. So we'll say bind. So I'm just giving you, I'm saying there's going to be a parser of expression type, but I don't know what it is yet. And I will tell you in a moment. So it's immutable in the sense that once you set it, it's set, but it's potentially not set, and there could be an error for that. So we'll have to watch for that. Alrighty, let's make it happen. Okay, so this is bind, and we'll start with a test. File. Export B combo. Bind can define parser later. Okay, so I think the way you want to use this, well, we almost had it up over here. I'll do this stuff here. Well, okay, we just have these sats. Let sat1 equals satisfy $0 equals 1. Okay, so I'm gonna let digit 1 can represent the digits. Left paren is satisfy Maybe let's do a negation one instead. 2. So we're doing a numeric representation or analog. Okay. So expression equals bind. I don't care what this is really. Recursive is the target type. Let's make it be int. Might be array event, but we'll get there. Okay, digit or minus and expression. Okay, so it's right recursive. Expr.bind parser. Okay. Now, that should give me a parser that matches matches this thing. So if I did let result equal parser.parse and I passed it 2 to 1, that's kind of like minus 7. All right. Let's pass in some extra at the end just to show we don't care. We could say check success on result, and the value should be 2 to 1, and the rest should be 9. And this is where I'm not sure the int versus the array and all that. Okay. Maybe this is array event. Okay. Now we need to bind. New file. Bind is going to look like any other parser. Well, many is probably closer. Okay, takes a parser, its input type. No, it's really taking a type, isn't it? T of just a type T. Okay, input equals. How do I know the input type? Is bind a parser? Maybe it's not. It is here. Type alias target equals T. The input, though. Maybe you got to tell me the input type, too. t, input equals n, and the target is t, okay, parser is p. I think that's what I'm doing. This parse function is character int to type int. Okay, this is my old one. It's really parse result. And the input is array slice of input. Okay, and this is parser function. I don't know, I'm getting a lot of stuff in here for this declaration. There is none. Okay. So that's none. This parser function is optional. Okay. Now here, this. Okay. Return from initializer without storing. That's nil. Missing return. Okay. Let's return a failure. Okay, but is this compatible? Input target. Okay, I think that part's all right. Bind tests. Okay, let's make sure everything builds. His input is type int. Bind in scope. Bind special input. We can't find it, and it's got the wrong number of stuff. Okay, I believe it. All right. Let's try again. Function requires the types int and bind int array of int to be equivalent. Bind int has no member bind. Okay, that we can address. Function bind, and it's going to take a parser function, and it's going to do something with it. Okay, in this case, we're not going to do anything. Did I have to make that public here? Okay. Converting non-escaping value to array slice of int may allow it to escape. Okay. I think that means we need to say escaping here. Okay, problem. Operator requires the types int and bind int to be equivalent. Okay, because the digit is int and minus minus is array of int. Okay, let's pipe this to this. We'll turn it into an array of ints. These types are something else, aren't they? My parser doesn't have the right type. That's the issue. Okay, and so let's see, go back where I was. Oops. Right, and cannot convert. His input is ints, his output is array of ints. Operator last requires target satisfy int and bind and array int be equivalent. This produces array events, that's fine. Now, why didn't it like... let's pipe this. Let's try that again. It got a value. If it gets its match, then its type should be an array. Okay, let's see what his type is. Pipe, satisfy, int, comma, array event. I don't see how. Type is satisfy int. Okay, this is pipe. Pipe satisfy int to array event. Okay. And then minus should be array event. Sorry, minus and expr. Okay, I don't know. The type of this, I want it to be array event. And then keep right, satisfy int, bind int, should be array event. Cannot convert core else. Let's see what the type of parser is. Or else, pipe satisfy intent, keep right. Golly. This is where it gets tricky. It's like... So, digit should be a parser. His real type is parser from ints to arrays of ints. Because he matches a 1 and returns an array of 1.
minus and expr. Am I really keeping just the second one? Or is that going to help? Bind and array events. I mean, this is an int, and an int should be array event. The type of negated. All right. Well, they say sometimes it helps to stop on a failing test, so I think that's what we're going to do. I don't see... I would have thought a pipe converts to array events. Maybe this satisfy int bind type int. Okay. Well, we'll pick up there tomorrow. So tomorrow is Eastern time, 10 a.m. to 12:30 p.m. or UTC is 3 to 5:30 p.m. And we made a lot of progress today, but we didn't quite get through this bind recursive one. So we'll see what we got to do tomorrow and go from there. Thanks for joining. Take care. Bye-bye.